So let us start with the fifth chapter. So here, indexing and hashing, you might have seen the index for any of the textbook. So there are two indices available in the textbook, one at the front side, and we are having another index called appendix on the last part of the book. So wherever we wanted to search any topic in the we right now we will talk about the final index, that is a which is on the last side of the page. So there we can see all the contents are in the sorted order, and these takes hardly 5 to 6 pages. When it comes to the larger books of 1000 etc., these might take almost 10 to 12 pages, which is very less number of the pages as compared to the complete book. And hence whenever we wanted to search about any of the topic, we can search alphabetically into that appendix.
Hello,
Yes,
madam.
yes ma'am.
Kada, madam. We'll take 5 minutes.
Okay,
We want to talk with students.
okay ma'am.
Okay. Good morning, students.
Good morning, ma'am.
Good morning. So, actually, Bhuneshwari madam is also present, and I am also present. So, we want to make aware to you people regarding GATE. So, you are lucky, guys. So, first time they are allowing third year students to appear for the GATE exam. So this is the chance given to you people. That's why I'm saying that you are lucky. So you might be aware what is the last date? Anybody knows to fill the gate form?
7th October.
Okay, Vaishali. So Vaishali knows the date also. So fortunately, date is get extended from 30 September to 7th October. So we request you all people, so as you are eligible, so you may get the chance, you may qualify the exam. So according to your level, the question paper will be there. So appear for the gate exam. So fill the exam form within the deadline. So instead of waiting for the deadline, so you can start filling now only. That is maybe today, tomorrow, within 2 to 3 days. Otherwise, if you are going for seventh, so server maybe get hanged. So number of students they are appearing or filling the form maybe at 11th hour. So just try to fill the form as early as possible and appear for the gate. You will get the experience. At least you will get the experience how the gate exam will be there, and you know what is the importance of gate. So everywhere you require gate. Am I right? So almost a number of companies they are also keeping the eligibility as a positive gate score. So if you do preparation for the gate exam, so that is helpful for your placement also. So you can there is no need to prepare for the placement if you do the preparation for gate. Okay. So hurry up, fill up the form as early as possible, and after filling the form, so take the screenshot and send it to your class coordinator. Okay. So especially again those who are interested in PG, so it is again compulsorily. So like CET, this is the exam for higher education wherever you want to go. So you require positive gate score. Okay. So fill the forms and send the screenshots to I think Kadam madam. So Kadam madam is your class coordinator. So Bhuneshwari madam, you want to speak? Okay, okay madam. So thank you students. So all the best. Fill the exam form and appear for the exam. So again, this is the mode of exam will be conveyed to you soon. But before that, as the deadline is there, so fill the exam form. Okay? Yes, madam. Thank you, madam.
Okay, ma'am.
Okay, you
Thank you,
can
ma'am.
continue. Ah.
Okay. So really, unless and until you study for the gate examination, basic concepts will not be clear. So I recommend everyone to appear for the gate examination. So let it be score anything, or let it be that you are not concentrating. Whatever your current TE subjects are there, even though if you study these subjects deeply, it means as a preparation for the gate, still it is very beneficial for you. So it means I won't take you, I don't say that you should go and study the BE subjects or any other subjects. So whatever SE and TE subjects are there, even though if you study them with the, it means with proper channel, that basic concepts are clear, still you can crack gate easily. And whatever gate score is there, that is a valid for 3 years. And as per our college policy, if consider you are having applied for the gate examination, it means this financial assistance is to the final year students, it means up to the last year, because they were appearing for the gate examination. So this might be extend to the third year students also. It means there is no guarantee, there is no any circular we have received about this, but for the qualified students, we are having 50% refund of the fees. Okay, so this is the instructions. So today, as Tamburi sir is busy with the CET examination, that's why I'm conducting the first lecture. Second lecture also will be conducted by me, but instead of continuing up to 2:45, I will continue up to 2, and 2 to 3 you can apply for the gate examination up to max 3:30. You should send me the screenshot today only. Okay, so this is my request to all the students, that you appear for the gate examination and send me the screenshot of your complete application form. And date is extended, it doesn't mean that you should apply for the 5th, 6th or 7th, etc. During the very last days, it means very whenever there is a deadline, a server got too much busy and gateways are closed. That's why I hope you all will apply today only. So I'm giving excuse for the 1 hour, and that much time is sufficient for the applying to the gate examination. So that was a discussion regarding the gate. Now let us start with the today's class. So we were talking about the indexing and hashing. So indexing always refers to indexing always right now we are talking about the index of the textbook. Okay, index of the textbook, which is having very low size, it means which takes very less space as compared to the complete contents. And because of this index, we can have, it means we are able to search the things very easily, that whenever we are looking for any concept, we can go through the appendix, search whether that concept is available. If it is not available, it means there are very rare chances that this concept may not be covered in the book, or that concept doesn't belong to that subject. So it means that here whenever we are searching any topic, first we go to the index, which is having very less space as compared, or very less size as compared to the uh, actual contents, and then searching, that is alphabetically these are sorted. So it means For the searching also, you need not to go for sequentially searching all the contents. You only search up to the limited part, and hence finding that element or finding that concept is very much easier. And then after searching the page number, we can directly to the go to the actual concept where that was explained in much more detail. So in case of database also, indexing refers to the same concept, that actual records or storage of actual records may take larger space, and in order to check or search any particular record, we might go through the number of, it means complete database or complete table or complete records, etc. And that may not be required, because here whenever we are asking for the query, always queries are it means based on the very short data or very small part of the database. And for searching or giving that output, if we keep our processor busy for this much longer time, that will be difficult or may not be efficient. And for this purpose, we use the concept of indexing and hashing. So under this chapter, we are going to cover these contents. So these contents already we have studied yesterday. We read these concepts, and now let us move to the first point. I hope up till now you don't have any problem in the listening or voice or any other. Clearly, my voice is audible to you. Okay. Um, Now let us see what is mean by indexing and hashing. So here, uh, indices or whatever the textbook appendix is there, that is always in a sorted order. It means that here elements order matters a lot. Now here in case of database also, we are having number of attributes are there. Let us take a table of instructors. Okay, in the instructor table, I'm having ID of the instructor, I'm having name of the instructor, department name, and then the salary. So here records may be random, that in the database there is no any fixed specific location that only at that point only record will be get stored. So here records may be get stored randomly, but whenever we are talking about the, it means the insertion order can be anything. Initially I may insert the instructor from the CSE, next mechanical, next ENTC, next physics, or there is no any specific order whenever we are inserting the records. But whenever we are trying to find out any of the records, for this purpose, it is better if we are having ordering of elements based on some criteria. For example, if I'm looking for the ID 777, etc., then if IDs are in sorted order, then it is easy for me to search that particular record. If consider I come at the uh, value which is greater than the 777, then I will make the conclusion that yes, that element doesn't exist in my table. Okay, so that is the importance of ordered indices. So here ordered indices works on ordering of the values or sorted ordering of the values. Sorted ordering, we can decide any attribute to perform the sorting. So there are many attributes are there, and indexes can be sorted on any of the attributes. Okay, so here ordered indices are based on the sorting of the elements, that elements are in sorted order, and then the index is formed. And then next concept is hash indices. So where we are applying some hash function to calculate the storage location of a, or deciding or finding out the storage location of the uh, any record. Okay, so these are just definitions. Let us see these points in detail. So here every index is not always good or bad, or always best or not worst. So here whatever the use or uh, feasibility of that method is there, that is completely based on many of the factors are there. So first is a access type. that is which type of access that are supported efficiently. That is, it means if I'm having the lengthier long data, etc., so it won't allow me to have a index on that. So it is always preferable to have indices based on the integer values instead of text indices, because processing the text, that is much more difficult as compared to the processing of integer values, where we can go for sorting or deciding the order, etc., very easily. Whereas if we compare with the text data, that gives us much more difficulty, as alphabetical assigning or element separation, that may be take a longer time. Next, there are only limited operations which we can perform on the character or string data, whereas on the integer we can perform comparisons, etc., very easily. Next, access type, it means which type of data we are accessing. Next, access time, it means that for finding out a particular data item, how much time it takes. Okay, so access time, it means that how much time it takes to access that index, and after accessing the index, how much time it takes to access that particular record. Okay, so access time, it means that the time it takes to find a particular data item or set of items using the technique in the question. It means for example, if I'm asking find out a name of the ID 1234, then I may look into the index 1234, and then whatever the location is there, to that location I will access the name. So that how much time it takes, that will be completely based on the index access time plus access of a record. Insertion time, that how much time it takes to insert new record. So new record inserting into a database will also update the index also. Deletion time, same, deleting a record from the index as well as from the complete database. Space overhead, that is how much space the index might take. And for all these purposes, we always use any attribute. It means attribute on which my index is defined. So an attribute or set of attributes used to look up records in a file is called a search key. Okay, search key, it means that this is an attribute on which basis the index is decided. If there are several indices on a file, there are several search keys. So, any doubt in these parameters? So, these are the parameters on which basis we are deciding which index to be chosen. So, let us see the first type of the indices, that is ordered indices. Ordered indices are sorted ordering of the elements is there. So to gain fast random access to a records in a file, we can use an index structure. That index is a data structure which we can use for the fast access. If the file containing records sequentially ordered, a clustering index or primary index is an index whose search key also defines the sequential order of the file. Okay, so for this purpose, let us see the example. So this is an example. So here, please go through this IDs. So all these IDs are in ascending order are there. Okay, if consider while storing the records. Okay, so if whenever I'm storing the records, I always take care that IDs should be in sorted order. So this is a based on the storage structure only. So here names are random, department name is also random, and salary is also randomly placed. So here whenever we wanted to add any new element, so if consider I'm adding 5 times 3, this record I wanted to add. Okay, so at this point record will be added, but in between this record and this record. Okay, sorting of the elements, it doesn't mean that I will be adding a record at this. No, here a record should be always placed after this record and after this record. So here you can see these are connected via a chaining, that is a linked list. So here this is holding a reference of the next element, this is holding a reference of next element, and hence whenever a database access this record, the next record should be of a new inserted 5 times 3 record. And then whatever this new record we have inserted, that will come here after this record, and this record will come after the that new inserted record, and that entry will be also made here in this table. Okay, clear with the scenario? Clear with the scenario, or should I go with the example? Okay, anybody else is having the doubt? So okay, let us continue with the current discussion. So here, if considered during storage only, we are maintaining this sorted order, and our index is also based on the ID, then this is called as a primary or clustering index. Okay, so primary or clustering index, it means that whatever our storage structure is there, if elements are stored in the sorted order of IDs, and there is a index available on the ID only, then we can say that this index is acting as a clustering or primary index. Now let us go through the definition of clustering. If the file containing records is sequentially ordered, yes, we are having sequential ordering of the IDs, and sequentially ordered, a clustering index or primary index is an index whose search key, it means the attribute, also defines the sequential order of the file. Whatever the order of my index is there, if elements are stored in the same order, then it means that that is a index, clustering index. Okay, so these two names are can be used in any way. It means clustering, it means primary only. Indices, so next concept, indices whose search key specifies an order different from the sequential order of the file are called non-clustering indices. If consider non-clustering indices or secondary indices. So for this purpose, we will take an example of the name. So if consider we are having index on the name attribute. So name attribute here, the storage sequential order is based on the ID. And if we define index on the name attribute, then here whatever the index contents are there, these will be in sorted order, but ordering of the elements is different. Yeah, no, this is not an else example. Okay, I will show you the example from the book for the non-clustering. So, okay, this is an example of the non clustering, or which you also can say as a uh, secondary indices, where the storage order is different than the sequential order of the elements. So here, if consider we are having index based on the salary, okay? So this is a index based on the salary attribute. So in the index, we know that always the elements are in sorted order. So these are the sorted ordering of the salaries, and these are holding the addresses of the records, but the actual storage is based on a id attribute, that these elements are sorted in the id attribute. But whenever we are having the index, this index might give the reference for the based on this salary attribute only. So clear with the difference between primary index and secondary index? Unbelievable. Students are still joining. So clear with the difference of primary and secondary index?
Mom,
Yes.
explain the once again secondary index, and I have a doubt like in the means primary index there is a means in our data there is a indexes, okay, but
Hmm.
there is not IDs present over there. Then how we can decide our cluster key or primary key?
What? Here ID is not there.
Ma'am, I'm considering my own example, okay.
Huh.
This one is right, okay.
Hmm.
What I'm trying to say to you, like
Hmm.
if we consider one kind of data means table format or data structure,
Hmm.
there is a having means that table having the indexes, okay,
Hmm.
but in that column list there is no any kind of column of ID, okay.
Hmm.
Then how we can decide our cluster key or primary key?
No, 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 no. Here, if consider whatever right now your table is having 5 to 6 attribute, okay? 5 to 6 attributes may be having any type of data. It means one may be name, that is character value, another may be some marks, etc., float value, or some other, etc. Okay. So if consider while adding records to my table, if consider you are adding those records, consider as per the name only you are adding. Okay. It means whenever we are inserting the records,
Ma'am, your voice is breaking now. It's not getting actually. Hello, ma'am. Sorry for interruption, but your voice is
I'm
breaking.
not audible. Hello. Yes.
Hello, ma'am. Now.
Let me check.
Now let me check. Am I clearly audible to you? Hello.
Ma'am, you're audible.
Okay. So here we were talking about few of the. It means your question is that if you don't have ID attribute in your table, and then how you can create an index on that particular table. Is that your question?
Yeah, ma'am. Yeah, ma'am.
Okay. So here my explanation is that even though you do not have any ID or any integer attribute etc., still we can have index on that. So whatever consider that there are three attributes are there. I will take an example of current table only, that you are having name, department name, and salary attribute. Consider salary is a float attribute. Okay, so here whenever we are storing the records, so it might happen that while storage only I have made the provision that elements will be stored as per the sorting of the department names. Okay, so that whenever we are searching for any of the department, I can get the all the instructors in the same way. It means here whatever this department name is there, computer science. Okay, so this is the first faculty, this is the second faculty, and this is the third faculty. Okay, these will come together. So it means there will be a sorting based on this attribute. So whenever I'm inserting any record, this will check what is the department name. So if consider computer science is the department name, so it will leave the first three records that it is the same value. And whenever it will move to the next record, consider next record is a finance record, then it will make a conclusion that finance is a value greater than the computer science. So after this last record of the computer science, this will insert a new record. This will insert a new record, and this always takes place in terms of a linked list. Okay, linked list is a data structure where we can add the elements randomly, and whatever the pointer to the next element is there, it will point to the new inserted record. Okay, so if consider right now Srinivasan is my last faculty from the computer science, and next I have added ABC faculty. Then after this Srinivasan, this record, a next record will be here ABC, computer science, and salary, whatever it is. And hence, after the ABC, it will point to the who from the finance record. It means here actual shifting of the records may not take place, but inserting a new record, so this link to a next record is there, that will be pointing to the new inserted record. And whenever we are performing any display or access of the data, so this will always work on this node, that is next element. Now is it clear? That is how the insertion will take place into a sorted order. And whenever we are performing the indexing, it means consider that my index is based on the computer science. Then here in the index there will be only single entry for the computer science will be there. And as there are four faculties are there, so here there will be four pointers will be there. Four pointers, first pointing to the first record, second pointing to the second, third to third, and fourth will be to the final record of the computer science. And whenever any new insertion is done, that will be here. The new node will be added, and entry will be also added to the index, saying that there is also a fifth record available in the computer science. So here, whatever 80,000 is there, okay, for the 80,000, we are having two instructors with the 80,000. This one from the electrical engineering and this one from the finance. So there are two pointers are there. Okay, for the single record or single value, there are multiple records are available. So in this way, if we are having multiple values for that, multiple records for that value, so this will hold an array of those values and it will point to those records. Okay. Now is it clear?
Yeah, ma'am, it's clear.
I hope, I think still you are having any doubt.
No, ma'am. It's clear, ma'am. You can move further.
Okay. Anybody else is having a doubt in the secondary indices, first indices, primary indices? So here, right now, if consider my storage order is based on the department name, and if I'm preparing index on the name attribute, okay? If I'm preparing index on the name attribute and elements are sorted in the department name, then here I will store the sorted ordering of the names and pointers to those records, that is a address of those records, and these will point randomly to the records. Okay, so here, just like primary index, we don't have one-to-one pointing etc directly. No, here we need to maintain the track where my actual record can be there. So whenever any new insertion or deletion is done, that will be also reflected in the index also. So let us read these definitions once. Indices whose search key specifies an order different from sequential order of the file, that is whatever storage order is there, that storage order is different from my index. Just like if I'm having sorting based on the department name and my index is available on the name, then such indices are called as a non-clustering indices or secondary indices. So all the files which are ordered sequentially on some search key, such files with a clustering index on search key are called as index sequential files. That is just like I explained right now, pointer to a next, adding new record in between. It means next pointer will be pointed to the new record, and whatever previous pointer was there, that will be made next to the new record. So those files, it means database files, are called as a index sequential files. So this is an example of the secondary index. So in the primary index, there are two subtypes are there. So right now we are talking about the primary index. Primary index, it means that whatever ordering of the index elements is there, in the same way storage of the those elements is also there. It means database files storage order and index, uh, those are same. ID sorting based on the ID in the file and index on the ID. An index entry or index record consists of search key value, that is a which value we are having, and pointer to one or more records with that value as their search key value. So here, whatever this index is there, we have seen this index. So index is containing a search key value. So whatever this ID's values are there, these are called as, it means ID will be called as a search key, and these are the search key values are there. And here next, that is the next part is a pointer to the actual record is there. Okay, so this is explained here. An index entry, that index record, consists of a search key value, that is value of the ID, and pointers to one or more records with that value as their search key value. The pointer to a record consists of an identifier. Okay, identifier of a disk block and an offset within the disk block to identify the record within the block. So, okay, whenever we talk about the data, so this is always stored on the disk. It means we are talking about the memory now. So, whenever we are talking about the memory locations are given. That is, it means we know in the microprocessor we have read from 0000 to FFF. It means 5 times F. These are the memory locations. But whenever we are talking about the current memories, so these are in terms of GB and TB are there, which are secondary memories are there, where my actual records are stored. Primary memory is always having very less space, and that's why whenever we are requiring any data, we are loading that data from the secondary storage to the primary storage. Okay, so here whenever we are referring to the index, we first take index into the primary memory, and in the primary memory, in the index, check for that record in which secondary storage or what is the secondary storage location of that record is there. For this purpose there are two parameters are there: disk block and offset. So disk block, it means there might be multiple disks available, and within that at which location the element is available. So these two contents are stored as a storage locations of that record. So only that page only we need to, or disk block only we need to fetch into the primary memory. I hope you have studied such points into the operating system and are clear with my explanations. If not, then I can show you the diagrammatically. Is it clear? Disk block and an offset. Let us see these subtypes in much more detail, dense and sparse. So here, dense, both are a subtypes of primary memory only. Primary index only. So let us see what is mean by dense index. The an index entry appears for every search key value in its file. Okay, it means that if there are 7 to 8 departments are there, then for each and every department there is a value or entry available into the index file. Then such types of index are called as a dense indices. So whatever possible values of search key are there, every value can be find out in the index. But so let us continue the same type. The index record contains the search key value and a pointer to the first data record with that search key value. The rest of the records with the same search key value would be stored sequentially after the first record, since because the index is a clustering ones and records are sorted on the same search key. Okay, in a dense non-clustering index, the index must store a list of pointers to records with the same search key value. So let us see the example for this, what it says. Yes, this one. So here we are having a search key value as a department name. I hope this figure is visible to you. Okay. So here we are having index based on the department name. That is a sorting order of the department names is there. And there are multiple entries are available for the department name also. Okay. So the explanation says that the index record contains a search key value and a pointer to the first data record with that search key value. So here, right now for the biology, we are having only single record. So this will point to the record wherever this biology department's instructor details are stored. Next, computer science. There are three instructors are there in the computer science. So index entry will hold for a value for the first record only. So okay, first record for the very first record, this is holding the reference, and whatever this first record is there, this will hold the address of second and this will hold the address of next one. So it means that even though there are three records are there, still we are having only single entry into the index. This is a one way, that is whatever name is there sequentially we can find out the this computer science. So if consider that I wanted to find out is there any IDs of all the instructors in the computer science, then in the index I will search for the computer science, biology getting false. So computer science, this record will get true. And hence, in order to find out every record of this computer science, I will go to the very first record, will take ID of first record, then check whether next element is also belong to the computer science. If so, get the ID of that record also and get the ID of next record also. And when it will go for accessing the next record, at this point, this will notice that this department is not having the matching value of the computer science. And hence, this will only list these three IDs only. So this is how the explanation is given. So let us read this explanation once. The index records contains search key value, that is a department name, and a pointer to the first data record with that search key value. It means a record of the computer science first record. The rest of the records with the same search key value. It means remaining two entries of the computer science value would be stored sequentially after the first record. So very after the very first record, these two values will be get stored. And since because the index is a clustering one, it means same sorting as that of the index key, search key. The records are sorted on the same search key. It means we will have computer science sequentially only. So in a dense non-clustering index, the index must store a list of pointers to all records with the same search key value. So here, dense is a type of wherever we are having every search key value stored, there only this will have a records all the uh, entry for the every search key value will appear. So let me have queries on this point, or you don't have any queries.
Ma'am,
Yes.
open that example of dense index. Yeah, ma'am. Means for computer science department, there have means three entry for it. Suppose they want to access only the 83821, means it having how much salary, then how we can access?
whether this will check whether your question contains a computer science. It means that
Yeah,
my question is that I wanted to find out salary of an instructor from the computer science with ID 83821.
yeah,
Okay, so
yeah.
if in the question only department name is given, then only we can use the index. Okay, so in the index I will search for the computer science. So this will go to the very first record. So right now first record doesn't contain this ID, so then it will go to the next link. Okay, next link, it means that the link for the next node. There it will check for whether ID is the given ID 83821. If not, then it will again go for the next record to check whether that instructor is available. At this point, this will check that yes, the ID is correct, and hence this will give the value as 92,000. Okay, so in this case we are storing only pointer for the first record only. Okay, first record, it means that in order to reach to the third record I must go sequentially only. That is the only choice available here.
Ma'am, that means it's very time consuming. It is okay with there is means three records. If there are multiple means 1,000, 2,000 records are there, then it have to travel since from first record to till means whichever result or whatever result we have given to it.
Okay, if consider there are thousands of records of computer science are available, there can be hundreds of records of biology may be there, or any other department may be there previously before, it means before reach to the computer science. Instead of going for, it means without index, if consider right now ignore the concept of index, the record always takes a much more space, and hence we cannot load the complete table into a primary memory. If consider you wanted to find out particular very last record from the computer science, which might be 100 or 1000 record from the computer science, before that there can be thousands of record or hundreds of records of biology can be there. But because of the index concept, we are skipping checking of these biology 100 records, at least 100 records we are skipping. And from the computer science, yes, if we don't use the index, we sequentially have to go, and after the biology, after searching the final hundreds of biology records, and after going through the thousands of computer science record, we can reach to the actual record. But because of the index, whatever the time required for checking hundreds of records of the biology is there, that got reduced, we can say.
Okay, ma'am. Okay, clear. It's all right.
Okay,
Yeah.
and in the index, it means whenever we are going for the index, etc., always the attributes are chosen which are having very different values. It means that here those values which are getting repeated frequently, those values are not chosen. Okay, if there are thousands or hundreds of records are there with the same value as computer science, then department name will not be chosen for the index. It will choose some another attribute like name or any other, that is a category of the IDs it will choose. It means if there are thousands of records are there for which I have to go for sequentially, then this attribute is not chosen for the index. Okay, that is the actually while choosing the index or search key attribute, we have to take that care. Okay. Anybody else is having a doubt regarding secondary or sorry, primary index dense indices? So here, this is regarding the this computer science or department name or dense indices. So now let us move to the next point. What it says next is a concept of sparse indices. So dense indices is having entry for every search key value. But because of this, if consider I'm having an attribute that is a index on the id, then id is a different attribute that for every employee or every student we are having different id. And if there are lakhs records are there in the database, we cannot store id for every value. So what it means, the size of the index will also grow. It means as my file records goes on increasing, the index size also goes on increasing, and hence it suffers from the same drawback that time consuming. Okay, but for this purpose we always use a sparse index. Sparse index, it means that instead of going for the every search key value, this only index is available for few of the value. Yes, this will be a ordered index only, that elements will be sort in the sorted order. But for every search key value, the index entry is not available. So let us read the explanation. An index entry appears for only some of the search key values. Okay, for only few of the search key values we are having the entries. Can be used only if relation is stored in the sorted order of the search key. It means this is only useful for the clustering index only. To locate a record, we find the index entry with the largest search key value, that is less than or equal to the search key value for which we are looking for, and we start at the record pointed to by the that index entry, and follow the pointers in the file until we find the desired record. Okay, so let us see what is mean by this sparse. This is a sparse index. Okay, so previously on the id we are having the index available, and for every search key value, for every different value, we are having entry available into the index. But in case of sparse indices, we only have values for the limited records. Yes, but these are sorted records. Okay, so it means in the file also we are having sorted records based on the id attribute, and whatever index is there, index is also in the sorted order. So if consider I wanted to find out Einstein record, okay, with the 6 times 2, then the explanation says that in the sparse index, first we will find out the first larger record than the existing value. To locate a record, we find the index entry with the largest search key value. Okay, largest search key value that is less than or equal to the search key value for which we are looking for. So for this purpose right now, if I'm looking for this 6 times 2, so this will compare with this 10101. This record is smaller, so we will move to the next record, 32343. So this record is having value larger than the 6 times 2. So this will move to the previous record, that is 10101. So this is the record which is smaller and largest in the all category, and hence it will go to that record and sequentially search for that record which is having the id as 6 times 2. It's okay, let me have the query. So okay, for a minute read this. For a minute, read this explanation, and then we'll explain in detail. Clear? Hello. Clear with the explanation? So shall I take one more example for this pass?
Yeah, ma'am, sure.
Okay, consider that I wanted to find out a record with 58583. Okay, this record I wanted to find out, and we are having index on the ID, that is a sparse index. Okay, then for searching this record 58583, so this will first look into the index whether that entry is available. So 10101, this is a smaller from smaller than 58583, so this will go to the next record. This is also a smaller entry, so again this will go to the next record, that is 76766. So this record is having the value larger than the 58583. So if consider this record is available, then there is fixed this record will be available after this record only. It means the possibility of existing this record will be after the presence of this record only. So we need to find out. It means here 7676, this value is greater, it means that there is a possibility of having record before this record only. So this will move to the previous value 32343. So this is the largest but smaller than the given search key value. So to the record, we find the index entry with largest search key value, that is less than or equal to the search key. Search key is 58583 and 32343. This is the largest record, which is a smaller than that record. So this will move to take this pointer and will move to this record. So here it will check that ID is not matching. So by using a sequential pointer, this will go to the next record. We'll check whether ID is equal to the 5853. No, no, and then it will come to this record. Now the ID is matching, so this will locate this record. Okay, so if consider, this is regarding the successful search. If consider we are having 60,000 ID. Okay, 60,000 ID, same procedure. This is the larger record, so go to the largest smaller record, go to this file, search element, no, no, and no. So at this point also this record is larger, so it will move to the next record. And at this point we are having the ID 76543. So this is a larger than the 60,000. So this will make the conclusion that yes, record is not available into the file. Okay. Am I clearly audible to you? Am I clearly audible to all? Okay. Clear with the current explanation? To locate a record. Okay. Uh, this was regarding the dense and sparse indices. So can anyone give me what can be the advantages of dense indices and what can be the disadvantages of dense indices? Yes, any clue?
Ma'am,
Yes.
for storing the dense indices means for
Hmm?
particular key there are means for particular ID there is a one dense indexes. Okay, so for storing that it also needed one kind of memory, but in the
Yes.
sparse index there are only we are limited means
Hmm. Yes. Yes.
from
Yes.
the sorting we are means what you can say, compress the key value like indexes. So it's better, means it utilize the memory, means
Yes, you're right. So here, the first drawback is that the dense indices are always too long and are difficult to maintain. It means whatever space overhead of dense indices is there, as this makes available entry for every search key value, always the dense indices are larger or takes much more space. Here only you can see right now 11 to 12 records are there and this is taking this much space. As compared to the sparse is having only 3 records are there. It means index size is very much smaller in case of sparse, and in case of dense this is much more larger is there. And there are few it means always whenever we perform insertion or deletion, always we need to update the index also. It means that here if I delete a record Einstein from this database, then along with that I need to perform deletion into the index also. It means insertion overhead is much more, that if I enter the record with the 6 times 3, I need to insert record into the database also, and index entry also we should make. And for this purpose, dense index is having much more maintenance as compared to the sparse. Whereas if we talk about the sparse, if consider I removed Einstein entry is not available into the index, and hence removal of this record from here doesn't make any changes to my doesn't make any changes to my index, first thing. And if I remove, okay, consider that history is said this record I have removed from the database. Then here, in order to perform changes to my table, instead of pointing to this record, only this record will point to the very next index. This will point to the very next record, and hence this can be in very rare cases it will be there, that along with the performing changes to my database, I need to perform changes to the index also. But in case of dense, this overhead is with the every record is available. Okay, so that is the first drawback, that is a space overhead and maintenance. And again, wherever right now id is one single attribute and there is no any repetition of the values are there, so the file size grows, then my record that is index also grows. So dense indices are at all not useful whenever we are having thousands of records are there, etc. Because here every entry is entered into a index, it means that index itself is going to get larger. Okay, in such cases dense indices are at all not preferred. But the drawback with the sparse is that here whenever consider that I wanted to search a record with the gold physics, that is I wanted to check whether there is any instructor in the physics department with the gold name. Then here in order to search this record, if I'm going for consider that my dense index is available on the available in the dense index on the department name, I directly go to the physics and search for a two records only I need to search. It means whether existence of value is there, that I can make conclusion at this point only. Okay, I will take some another example. So I wanted to search instructor with 33456. Okay, this record I wanted to search. Available into my database. So in the index I will search for this record. At this point I located this record and I directly. But here it means that at index level only I come to know that there is a record available in my database. But in case of sparse indices, I cannot make conclusion at the index level. I need to go to the actual records and then check whether record is available or not. And hence I cannot locate my result or limit my result to this point. If consider I'm looking for 60,000 record, Okay, ID instructor with ID 60,000. Then I cannot make conclusion in the index only, but at this, in case of dense indices, I can make the conclusion at the index level only that yes, this record is not available, and hence we need not to go to the database and search whether this record is available or not. So dense indices having its own advantages and disadvantages, and so as with the sparse. Okay, clear? Clear with the advantages and disadvantages of the dense and sparse. Okay, no doubt it means I can move to the next point. Next concept, that is a multi-level indices. So, multi-level indices, it means you might have uh, guess what why this name can be. So, take a time and read for a minute what this is. So here, level of introduction, level of some one it means levels are added. So let me show you the figure. So this is an multi-level index. So instead of having one only large index holding all the records, we subpart this indices, and just like we store starting locations of every block, next block, third block, fourth block, etc. In the same way, in the index also we store only the starting search key value and maintain this index. So let us read the definition. So indices with two or more levels are called multi-level indices. Yes, we are having lakhs of lakhs records. And for this, instead of having single, yes, main large index is available, but this index might be spread on multiple disk blocks. Okay, for this purpose, we add a level of indirection where we keep only the starting addresses of every disk block where this index is stored. Then, searching for a record with a multi-level index requires significantly fewer IO operations than does searching for records by binary search. Multi-level indices are closely related to tree structures such as binary trees used for in-memory indexing. So here is this physical whiteboard. Okay, all the students, is this whiteboard visible to you? Students, is this whiteboard visible to you? I have provided a link in the chat window. So please click on that link. So you will get this whiteboard shared with you. Okay. Instead of this, we are fine with the slides only. So I will use the slides for this explanation. So here, multi-level index means that whatever our current existing values are there, for that values, we are maintaining this actual record. So consider that here, actual I am having the records. Okay, so here I'm having the first record 1000. Okay, second thousand, etc. Okay, consider I'm having sequential entries of the index sets are available 1001, 1002. Okay, and similarly I'm having another record. It means many more records are there, 2000, then 3000 records. Okay, these are the consider IDs of the instructors are there, and this is a index for which we are having the entries available. So two level indices, it means that first entry or whatever this complete index is there, this may not be sufficient. It means one disk block may not be sufficient to store this index. Okay, it means this disk block is this index will be spread on the multiple disk blocks. Okay, consider first disk block contains records up to 3500 only. Then there is a second disk block. Okay, there is a second disk block which is storing records from 35001, sorry, 10, and next onwards. It means here also we are having all the records, database records. So this might be taking up to 4000 and so on. Okay. And consider here we are starting from records from 5000. Okay, so here if consider particular value, consider that I wanted to search for 5500. Okay, this value I wanted to search, then If I'm having only single level or single index is there, or only one dense index is there, then I will load first this block, will search whether all the elements are greater than or less than 5500 is there. Here there are this element is smaller than 5500, then I will go to the next this block, search this record or search all this complete index. Here also I couldn't find out the 5500, then I will go to the last record and here sequentially search. I will find out that yes, whether record is existing or not existing. So here it means that for searching within the index, I need to perform this page, bringing into primary memory, then sending back to the secondary memory. This page also loading into primary memory and searching whether the record is available. If not, again swapping out, and then this page swapping in and searching for a record. So it means that this disk access are there. These are giving me the false. It means these disk access got vested. So for this purpose, we are introducing a level of indirection. Level of indirection, it means that whatever my main index is there, I will make a index of that index. Okay, so it means that there might be some address given for this disk block, for this disk block, and this disk block. So it means here I will hold this 1000 entry. Here I will hold starting location of second disk block, and at the third I will hold the starting location of 5000. Okay, and hence uh, and will make pointers available to these. Okay, from this will point to this. This will point to this record, and one more. This will point to this record. Now consider that I wanted to find out 5500. So initially I will load only this disk block and will search whether in this block the disk the entry can be found out. So here again for searching the given this will be a sparse index. This is not a dense index. Okay, this is having only limited records are there. So then it will search for 3500 Again, this is a smaller record. 5000, this is also a smaller record, but there is no record further available. It means that chances of having the record is available in this page. So directly it will move to this disk block, search whether element is available, and then directly go to the record. So this is how the multi-level index works. So the multi-level index, it means that indices with two or more levels are called as a multi-level indices. Searching for a record within multi-level index within a multi-level index requires significantly fewer IO operations. Okay, right now we are having only three disk block, but there can be multiple also because lakhs or thousands of records are there. So this disk block count also may reach to the hundreds, etc. So for this purpose, we are maintaining a index on these, and hence only loading this page is sufficient instead of swapping in this page, swapping out, swapping in this page, and swapping out. Instead of that, we can load this. So this might be keeping the complete track, even though there are multiple or hundreds of disk blocks may be there for which index is spread. Still, we can load only this much, and only single swapping in and out is sufficient. Fewer IO operations than does searching for records by binary search. So binary search also can be applied for this. Multi-level indices are closely related to tree structures, such as binary trees used for the memory indexing. So regarding this, we will study into B plus tree, where this structure is very similar to the next structure. Two level sparse index. Two level sparse index, it means this is my actual database. For this purpose, we are keeping the sparse index for block 0, block 1, or etc. It means this block is index for these two blocks and so on. So we are keeping the index of this index. So it means the outer index is available. So whatever this inner part is there, the main index, this is a inner index and this will be the outer index. And these are my data blocks. Clear with the given explanation? So okay, let us go for the next point, index update. Um Index update, first we describe the algorithms for updating the single level indices. So here right now, forget about this multi-level. We are talking about this single level index. Okay, there is only one index available on the given database file, and there is no any level of indirection is also there. So index update, first insertion operation we will carry out. Insertion first, the system performs a lookup using the search key value that appears in the record to be inserted. Okay, so whatever record may be having multiple attributes, it means if we are inserting instructor record, we will have ID, name, department name, and salary. And within that, if we are having index on the ID attribute, we will check the value of ID to be inserted. Okay, so first the system performs a lookup using the search key value that appears in the record to be inserted. So lookup, it means that into the index, this will search for the search key given ID value. The actions the system takes next depends on whether the index is dense or sparse. So okay, so there again in the ordered indices we are having two subtypes, dense and sparse. So the scenario for these two is also different. So let us see what is it. So first, dense indices. If the search key value does not appear in the index, so we know that for the dense index, for every search key value, the value is available or record is available into the dense index. And hence, if the search key value does not appear in the index, the system inserts an index entry with the search key value in the index at the appropriate position. So in this example, if consider we wanted to insert the 6 times 3 record, it means ID is a 6 times 3. So then in the index, this will search for the record, that is lookup will be carried out. So at this position, when my lookup reaches or when I'm comparing my given ID value with this value, so here we can conclude that yes, the record for this value is not available and hence it will update the index. It means whatever here after this entry is there, it will perform addition of that entry or insert that entry in between at this index. So first step is over. Next, otherwise the following actions are taken. So wherever search key is found into the index already, the following actions are taken. If the index entry stores pointers to all the records with the same search key value, That is, if we are storing value for every record, and in the index also we are having storing the search key values for every record, the system adds a pointer to a new record in the index entry. So this means that here right now for the computer science we are having only single entry, that is a single entry from the index is there. But whereas if we take a case of this figure, okay, so here for the single entry we are having multiple pointers. Okay, if multiple pointers are there, then pointer will be added at this state will be there. Else, second step is there, if pointer for every search key value is available, while inserting the next record for the same value we will add a pointer to this, and we will make that pointer to the actual record. If the search if the index entry stores pointers to all the records with the same search key value, the system adds a pointer to the new record in the index entry. Okay. Otherwise, the index entry stores a pointer to only first record, just like we stored for the department name with the search key value. With the search key value, the system then places the record being inserted after the other records with the same search key value. Okay. So if consider we are storing record for the computer science in this, then there is only single pointer stored for all the records of computer science. Then it will go to this record, and at the last this will insert this computer science. Otherwise, the index entry stores a pointers to only the first record with the search key value. The system then places the record being inserted, the new record we wanted to insert, after the other records. It means what are the computer science records are there after that with the same search key value. Okay, what are the same search key, that is computer science many instructors are there. So after those records this will add a new record. So now this one is much more easier, sparse index. So I hope you take a minute and read this index update. So okay, let us go to the sparse index. So we assume that index entry stores an entry for each block. Okay, so something going wrong. So here not should be there in the first statement. We assume that index stores an entry for not for every block. So if a system creates a new block, it insert the first search key value. It means whatever the new search key is there in the search key order appearing in the new block into the index. And on the other hand, if new record has the least search key value in its block, the system updates the index entry pointing to the block. If not, the system makes no changes to the index. So here, meaning with this explanation is that if consider that entry is available for the uh, given search key. Okay, so here right now consider that we are having entry available for the 32343 and okay, new block. Okay, for this purpose I have one disk block, and whenever I'm inserting the new record for this purpose I need to go for a second new memory block. In this case, if we are going for the new block, a entry will be added to this structure. Okay, new entry will be added to the given table, and that's why this will update the database also, and this will update the index also. First thing. Now consider that right now we are having in the same block we are inserting the record. Then here consider that I am inserting record for the 6 times 7. In that case, whatever my current values are there, now at this point I come to know that I can insert the record after this. So this will directly go here. We'll check, yes, this record is smaller. Next, this record is larger. So it means that you need to insert the record in between these two. Then it will make the reshuffling of these pointers, enter the new record, and will not make any changes to the index. Here we will not perform any changes. But if up to this point the index is complete, disk block is complete, and I am inserting record for the 6 times 9 and new memory block is required. In that case, a record that 5 times 6 times 9 will be added here, and this will point to the new disk block. Okay, the same explanation is given here. If a system creates a new block, it inserts first a search key value in the search key order appearing in the new block into the index. On the other hand, if new record has the least search key value in its block, the system updates the index entry. So here, meaning with the last point is that right now we are having ID at this point, okay, 10101, and I try to insert the record with 10,000, okay, 10,000 value. This is a smaller than this value. So in that case, list value is there, then 10,000 record will be added here, and this entry will be also added to the index, and this 10,000 pointer will be pointing to the new record. Okay. So regarding this in detail, we will see into the next lecture. We will take a pause here. Okay. And do not remain absent for the next lecture. 1 hour lecture we will conduct. And next 1 hour, you can apply for the GATE exam.